All right, so we're going to pick up with the conversation about our pattern recognition or in our tables, and we just completed the little activity where we had to kind of look at the skips and jumps and think about like what does rate of change really mean, and this really gets into the idea of our unit rate of change and how we have to apply that if our change in x isn't going by 1 every time. All right, so we're going to really work on that, right, and try to work to everything down to this unit rate to determine if it's a constant rate of change. All right, so now when you look at what we're going to focus on in this particular lesson, right, once again, it's all about linear patterns right now, right? I can identify a linear function from a table of values. I can identify the rate of change for a linear function from a table of values. And I can now, here's where we're going to add a little bit more. I can now find missing values in a table or extend a table, right, using my knowledge of rates of change. All right, so there's no opener this time because the activity was really kind of the opener for this lesson. So we're going to really just jump right in and start looking at, all right, our rates of change and seeing what we have. All right, so now when I look at what I have right here, all right, I'm going to look at my left side of my column right here. All right, and all my x's are filled in. So what I want to do is look at how my x's are changing, right? So if I look down the left-hand side, it looks pretty good. So I'm going up by 1, going up by 1, going up by 1, going up by 1, and now I go up by 2. All right, so a little bit different there at the end, right? Now let's look at how those y's are changing. All right, and I kind of look at what's happening here. So I'm going to go from here to here, that's plus 10. All right, when I go from this guy to this guy, that's plus 10. And notice I'm skipping some things in the middle. Right, there's that jump that we talked about and we looked at in our exploration. Then from here to here, I go up 10. All right, and then I can see that this jump right here, I go up 10 as well. All right, now once again, let's look at the ratio, right? Because our rate of change is our change in y to our change in x. And if I go down here, notice this is 10 to 2. So if I write 10 to 2 right here, right, that's not my unit rate of change. My unit rate of change, I have to reduce that, and that gets me to 5 to 1. Now, let's go back to the other values in our table here. So notice here, this is plus 10, right? So my y changed by 10. But notice if I correlate that to what's happening over here, I'm going from 2 to 4. So my x's also went up 2. So I get that rate of change of 10 to 2 again. So that's 5 to 1. Same thing here. I go 26 to 36. That's up 10. I go from 4 to 6, that's up 2, and there's that same rate of change. It gets me to 5 to 1 again, 10 to 2. And my change here again, I go up 10, I go up 2 here, so 10 to 2, and that's 5 to 1 as well. All right, so now I can see that, oh, okay, it really is constant, right? So I can see that my unit rate of change is a constant of 5 to 1. And my rate of change, right, you can write that either way, right? It looks like it's a constant of 10 to 2. And we know, right, if it's a constant rate of change, right, or if you want to put 5 to 1 there, that's okay too. And we know if it's a constant rate of change, then that means that this is, in fact, a linear function. All right, so now when we go back in, we want to fill in these changes here, right? So now notice this goes up by 1. Right? So if x goes up by 1, I want my y to go up by 5. So that means I need to add 5 right here. Right? So plus 1 plus 5. So there's that 5 to 1 that I have right here. And then 16 plus 5 is 21. Now if I'm doing this right, I have a plus 1 here, so that means this has to be a plus 5. There's that 5 to 1 again. 21 plus 5 is 26. It's fitting that pattern, right? And so you want to double check that. Even though it's already written in, you should be able to continue it and hit all the values, all right, in your table. Now, once again, I have a plus 1 here, so I'm going to put in that unit rate, which is a plus 5 for my y. So 26 plus 5 is 31. I go back to my unit rate here, another 5 to 1. That gets me to 36, so that seems to be right on. And then one more here for my unit rate is a plus 5, so 36 plus 5 is 41. And I can see if I put another plus 5 right here, 41 plus 5 is 46. So that's really where that unit rate comes in, right? So we have to be able to adjust that based on, all right, what we see everywhere. All right, so now when we look at the next problem here, so let's look at problem 2. Once again, I've got some y's, I have some blanks, I got some jumps, but I see that my column here on the left, right, is completely filled in, right? So let's look at all those changes in x's first. So my first x goes up by 3. My next x goes up by 3. And then 4 to 7 is up 3 again. And once again, if I'm going too fast, you can pause it, fill in what you need to fill in, turn it back on. Plus 3, plus 3, plus 3, plus 3. I really like that, right? Because now this is all the same, right? Versus here, right? Okay, so now let's look at what's happening with some of our y's here. So when I go from 14 to 5, I go down 9. All right, and when I go from 5 to negative 13, I go down 18. It's a big jump there, right? And then when I go from negative 13 to negative 22, all right, I go down 9 there. And then negative 22 to negative 31, I go down 9 there. So I have a couple different rates of change, right? And so when I look at this, this is negative 9 to 3, right? Negative 9 to 3, negative 9 to 3. So those are all the same, right? So I can definitely see that it looks like it's constant. Now let's look at this. I go down negative 18, but I'm going from this cell to this cell. So I go down 18, but I'm also going from 1 to 7. So I'm going up 6. So there are my rates of change. Now, the question now is, do they all have the same unit rate of change? Because if they do, then that means it's a constant rate of change. That means we have a linear function. All right, negative 9 over 3 reduces to negative 3 over 1. So that all seems to be good right there. Negative 18 over 6, that also reduces to negative 3 over 1. All right, so our unit rate of change is that constant of negative 3 to 1. All right, and really with your constant, right, rate of change, and you can list any of these because they all mean the same thing, right? Negative 9 to 3, negative 18 to 6, negative 3 to 1. All right, and so now my function, I know because it's all constant, is in fact a linear function, just like that. All right, so now let's go back and like fill in the puzzle, right? So now I know every time x goes up by 3, y has to go by 9. So notice all my x's go up by 3, so I know for each interval of 3, my y has to go down by 9. So this should go down by 9. So 5 minus 9 would be negative 4. And then notice if I subtract 9 there, negative 4 minus 9, that's negative 13. And so I can see that it fits the pattern in your table, right? So don't just assume, double check your work, all right? It's like a built-in self-check on all the work that we do. Another plus 3 means y has to go down by 9, so that would be negative 40. Another plus 3 means y has to go down by 9, and that's negative 49. All right, so there you go. All right, so now when we look at the work, right, if we have these, this is really easy. All right, we can fill in those values. All right, let's do one more together. All right, and look at what we have here. So now let's look at problem 3. All right, now once again, I can see that I've got some gaps in my y's. All right, okay, so I'm going to start looking at that x column first. All right, and I'm going to look at my rates of change for x. So I can see that I go up 5 on the first one, and then I go up 5 on my second change. 2 to 7 is up 5 again. 7 to 12 is up 5 again. 12 to 17 is up 5 again. And we can finish this off by going up 5 and then up 5. So I get all my rates of change for x's are up 5. So that's really good. All right. Now, here's where we have to do a little bit of thinking, right? Because I have a jump, I have a skip here. So notice I go from negative 34 to 16. So I went up 50 right there. I went up 50. And then when I go from 16 to 66, all right, I go up 50 again. All right, and then notice here though, I'm going from 66 to 141. All right, I'm gonna have to do that on my calculator just to make sure I get that right there. So 141 minus 60, all right, we went up 81. All right, so let's look at that. Okay, all right, so now, all right, did I do that right? So 141 minus 81, all right. I typed it in wrong. Or no, hold on. Let me pause the video. Let me double check that. All right, so I found it. I was hitting the wrong key on my calculator. All right, so this should be a plus 75 here. So if you want to correct that really quick. So 141 minus 66, I was putting in 60 instead of 66, and that was why it didn't seem right to me. All right, so now let's look at our rates of change. All right, so we have 50. All right, okay, we go up 50. I'm going to write that right here just to get a little bit more room. But notice I'm going from here to here. So -8 to 2, all right, means I went up 10. And same thing here, I go from 50, all right, but then I go from 2 to 12, that's also over 10. But then notice here, I go from 66 to 141, that's up 75. But I'm going from 12 to 27, right? So that's up 15. So I get 75 to 50. All right, now once again, we have to ask ourselves, okay, let's get to the unit rate and see if that unit rate is, all right, constant. So notice 50 over 10 reduces to 5 over 1. 50 over 10. All right, so we can see that we have, all right, that same unit rate and it's constant, right? So we know we have a constant of 5 to 1. And because it is constant, we know that gives us our linear function that we were hoping to see. All right, and then now when we think about that rate of change, once again, you can put any of those three. They all mean the same thing. So constant of 50 to 10, right? Or 75 to 15, or 5 to 1, right? So you can put any of those in that you need. Now, here's what's nice, right? Okay, now, all right, every time x goes up by 5, right? Okay, I gotta figure out what y goes up by. So this is where we have to use that unit rate. So remember, this is our change in y. That little triangle means change in x. All right, so this says every time x goes up by 1, y has to go up by 5. But notice I want x to go up by 5. All right, so I want x to go up by 5. So now what do? Right, I have to use my knowledge of fractions. I'm gonna go right up here, right? So 5 to 1. All right, so that's our change in y to our change in x. And I want this to be a 5, right? Because I want my x to change by 5. So I'm going to use my properties of fractions. And I'm going to multiply by 5. Now, here's one of the properties of numbers. I have to multiply by 5 over 5 because that's really like multiplying by 1. All right, and what this tells me is that now, notice 1 times 5 is 5, and 5 times 5 is 25. And that kind of makes sense, right? So for every step, right, I increase by 5. So if I go up by 5 steps, 5 times 5 is 25. So what that is telling me is that every time x increases by 5, y has to increase by 25. And so now I have figured out how to do the rest of my table, right? So now I know this has to be plus 25. All right, so negative 34 plus 25 is negative 9. And then this has to be plus 25. Negative 9 plus 25 is 16. All right, 16 plus 25, all right, is 41. All right, 41 plus 25 is 66. Perfect, right? 66 plus 25, all right, is 80, is 91. All right, and then 91 plus 25 is 116, and then 116 plus 25 is also 141. All right, so this idea of the unit rate of change and then converting it, right? So we're going to have to convert that unit rate of change to fit our change of x when it doesn't match what we originally had. So notice number 2 worked out really well because everything was plus 3, but we already knew what y changed by 3, right, with x's. All right, and so that's going to be the real challenge, right, is making sure we move in and out, all right, based on the change of x's here, all right, to correlate with our unit rate of change to make sure we have the right change in y. All right, and we will pick up with this in class, and I will see you then.